What if you could deepen user engagement through natural voice-enabled experiences? I'm Rachel Choi, product manager at Meta, and today you'll also meet Aaron Jackson and Julian Odent from our team. Last year at Connect, we announced Voice SDK, part of the Presence platform. Today, I'm happy to share how we're expanding our offerings, improving performance, and making it easier for developers like you to use Voice SDK. By the end of our talk, you'll know how to get started building today. First, let me share the voice-enabled experiences that developers have been building with Voice SDK.
Come here. Jump for me.
Let's play any song. Let's crank it up. Push. Slow. Shield.
Freeze.
What?
Drop your weapon.
If it eases your mind.
Get on the ground.
I'm doing it. Just take it easy.
Mega Boom.
Tell me a story.
Okay.
Make it this big. Summon butterflies.
Move closer to me. Turn on the radio. Turn on water.
Make some noise.
That last demo is from Whisper, a game we've built now available to you on GitHub. These are just some examples of what you could build with Voice SDK. Now, let's check out the improvements that we've been making. First, text-to-speech is now available, and we're starting off by offering these two voices.
This is one of the voices available in Voice SDK.
And this is another one of the voices you can choose. You can also adjust voices by changing options like the speed.
I can talk fast like a rabbit, or as slow as molasses.
Very funny. I'm a rabbit, but I can talk like a robot. Robot. Robot.
Say again, robot? It's a little hard to hear you in space.
We can't wait to see what you build with our TTS voices.
In V44, we introduced a new dictation module to Voice SDK. Dictation is pure audio transcription, no intense entities or traits. Now, you can get the transcription from longer audio, and there are many ways you can leverage dictation in your game or app. If you need mic support in your in-game keyboard, dictation can really help. What's more, you can build experiences like this sticky notes example for reminders. We're also introducing Voice SDK Toolkit, an open-source project aimed at sharing foundational assets, building blocks, and samples for common interactions when creating a custom voice experience. Available now, we're providing new toolkit components to help you onboard a user, help them understand the systems you've created, and handle errors effectively. Creators want to rapidly prototype these voice-driven experiences, so we're releasing design guidelines with the toolkit to help you do just that. You can download the Voice Toolkit today on GitHub. Simply add it to Package Manager or clone the repository's content directly in your assets directory. Keep checking the repository for new assets and tools. We'll continue to add to this resource. Now, for the new launch announcements. We're thrilled to announce the release of Voice SDK for Unreal Engine. And here's a first-hand look at what DigitalLoad has built, leveraging this integration.
Hi, I'm Donnie, Technical Director at DigitalLoad. Voice commands was a promising feature in the first Aspire game. In Aspire 2, you want to take it to the next level. The Voice SDK was a perfect fit for us. We were really impressed by how the voice AI was able to interpret the player's intent, and so we could easily turn that into the action they want. This is something that we only dreamed about in the first game. In Aspire 2, players have multiple commands where they can hold up and interrogate guards, and also use their voice as a distraction tool. Players got a chance to try out the Aspire 2 demo at Gamescom and PAX, and voice commands were a standout feature. Players really loved being able to talk to the guards.
Freeze.
What?
Over here.
Who said? Huh? Someone there? Anyone else hear that?
We're really excited about adding Voice SDK to Unreal Engine. Out of the box, we will be supporting Unreal Engine 4.27 and UE5, with support for immersive voice commands and text-to-speech. We will continue to expand these capabilities. Voice SDK for Unreal Engine consists of two modules, now available in GitHub. These modules include the Voice SDK Unreal module, which is responsible for developer-facing Blueprint nodes and APIs. The second contains the WIT Unreal module, which handles communication with the wit.ai servers within your application. Both are required to use Voice SDK. You can download the release zip from the Voice SDK Unreal repo, which contains the full package, or you can clone them individually. If you download the release package, extract it in your project's plugins directory to install it. Remember, if you clone the repo, the main branch of GitHub is bleeding edge. You'll likely want to check out one of the tagged release commits for your project. Once you've installed the plugin, there are a few things you'll need to do to get voice commands working on your project. First, you'll need to add support for voice to your default engine.ini file in your project's config directory. Add the voice-enabled property you see here at the end of the file. Once you've updated your default engine.ini, go ahead and restart Unreal Engine. You'll see a prompt indicating that Voice SDK and WIT Unreal need to be compiled. When the compilation is complete and Unreal Engine has restarted, you should see Voice SDK and WIT in your list of enabled plugins. A WIT config is a data asset that provides Voice SDK with the tokens needed to access WIT AI, the service that backs Voice SDK. You will need a WIT config file for each WIT application that you connect to. To create one, go to your content browser and add a new data asset with the Add button. Data assets can be found under the Miscellaneous category. When the class chooser pops up, enter WIT in the search box and then select WIT App Configuration Asset as the base class. Once you've created your configuration file, open it up and add your client token. You can learn more about WIT apps in last year's Connect session or in tutorials on developer.oculus.com. Now that you've verified your Voice SDK installation and set your tokens, it's time to set up your App Voice Experience actor. This actor maintains the connection to an app on wit.ai. Generally, people stick to a single app voice experience in a scene, but there are use cases that might call for more than one. For example, if you have an immersive in-game voice experience and voice-based menu control in the same game, you might want to create a different WIT app for each. By splitting these into two WIT apps, your utterances used to train the menu don't overlap with the immersive experience, and it'll further improve the speech recognition accuracy for the context you are actively in. You have two options for adding a WIT app. You can drag the base app voice experience actor directly into the scene, or you can create your own actor blueprint that inherits from it and add that instead. I prefer to create a blueprint so I have a dedicated place to handle activations and responses. To do this, first open the content drawer and find the directory you want to put your blueprint in and add a new blueprint class. When the Pick Parent Class dialog pops up, expand all classes and enter App Voice Experience in the search bar. Then choose App Voice Experience as the parent class. It's up to developers like you to decide how you want to initiate voice commands. Voice SDK provides an activate method that can be called when a user is ready. As an example, let's bind the T key to activate voice commands. Open up your App Voice Experience Blueprints event graph. Add a new node and find the T key node. Now, create and activate voice input node by dragging from the pressed pin. There are several ways to react to a response from voice commands. You can react to an intent alone, you can react to an intent and its corresponding entities, or you can decide just how you want to handle the response directly. The most basic way to handle responses from a voice command is to add an event to listen for on-wit response. This event provides a structure with all of the data from your activation, giving you full control over the logic for reacting to that response. This is great if you need full control over your WIT app's understanding payload. Since there's no built-in logic, these blueprints can naturally get complex quickly. If you don't need fine-grained control and are simply reacting to intents, you can use a voice intent matcher component instead. These have a field to specify an intent name, and they will receive an event anytime an activation is completed that includes the specified intent. These work great for simple utterances like fireball, or actions that don't require entities. The voice intent with entities matcher component provides options to match intents as well as the presence of entities. In details pane of the component, you'll find fields for the intent name, as well as an optional and required entities. The intent itself can be made optional, but the matcher will not trigger its event if it is missing any entities provided in the required entity names field. Now that we have voice input set up, let's add TTS to your app to get some audio feedback going. Minimally, text-to-speech requires 2 pieces of data and a TTS speaker actor to function. The required data assets consist of a WIT config and a TTS voice preset config. The WIT config can be the same one you used for voice commands earlier. It simply provides the token needed to make TTS requests. TTS presets are also data assets that you can create through the content drawer, but to simplify things, you can create one in a TTS speaker directly. To demonstrate this, let's add a TTS speaker actor that will function as an in-game announcer. We start by creating a new blueprint. Navigate to the content drawer and add a new blueprint class. Set its parent class to the WIT TTS speaker. The TTS speaker actor has an audio component, caching mechanisms, and a WIT TTS service. These components can be used to customize how your speaker works. As mentioned before, we need to set the data assets for your speaker. Select WIT TTS service and choose a valid WIT config and speaker preset. If you don't have any presets, you can add one here using Fetch Voices and Create Presets buttons. Once you've created a preset, click the preset field and select one from the dropdown. Let's add a custom event to make announcements with one of the built-in DSP effects. First, create a new custom event called Announce. Next, add a format text node and connect the event and formatted text to a speak node. Let's enter some SSML into the text format to allow text input to be spoken with a public announcer effect. To test it out, let's play an announcement that the game is about to begin. Create an announce node and connect it to the begin play event. Set the text parameter to the battle is about to begin. Now all you have to do is drop your blueprint actor into your scene. That's it. Let's try it out.
The battle is about to begin.
You should now have dynamic text-to-speech fully set up in your project. Keeping your users informed about what you're doing with their voice is very important. You should try to be very clear when the mic is active and what text is being seen by wit.ai. To accomplish this, you should include some form of attention system. This attention system can be fully immersive and part of the game or a part of the UI instead, whatever best fits your app. Voice SDK has included the events seen here to provide this feedback to your users. To get you started, we're providing a few basic samples and utilities in the repository. You will find the Shapes demo in one of the sample directories. We also have a couple of useful blueprints set up to get you started with your UI. You will find some basic actors to show microphone feedback, transcriptions, and activation state. If you want to add the samples to an existing scene, simply add one of the widgets in your level blueprint. I need air support in Sector 7.
Roger. Commencing bombing.
You'll notice with the radio example here, we are driving text feedback, activation state, and microphone activity in a fully immersive setup. There are many ways to incorporate this type of feedback into your app, and it's very important to do so, both for clarity and to help facilitate the privacy of your users. Let your attention system fit your game. Your imagination is the limit. Now, I'd like to hand it over to Julian to introduce our next big new feature.
Voice SDK is a great solution for handling simple voice commands. But we want to go beyond simple intents, entities, and traits as provided by wit.ai. Truly natural language interactions involve dialogue state, contextual awareness, and dynamic responses. I'm excited to announce the beta release of Composer for Wit and for Voice SDK in Unity. We're launching Composer to support rich conversations. With the Wit web app, you can now design the way each interaction is handled by your app voice experience. By connecting interactions together as visual components, you describe exactly how you want your experience to respond to each user input. This allows you to take advantage of all relevant contextual information while utilizing intents, entities, and traits like before. There are 4 simple building blocks you can use to create conversation maps in Composer: inputs, responses, decisions, and context. First, inputs. Inputs are any point in the voice interaction that triggers a response to the user, such as an audio wave from the user or a reminder firing off. But in practice, inputs are simply API calls. Second, responses. Responses are effects perceived by the user that result from the input, such as a natural language response issued by an NPC or a sphere growing in size. Responses describe the payload you'll get back from your API calls. Third, decisions. Decisions are branching points in the interactions that lead to different responses under certain conditions, such as the user intent, what objects and characters are in the scene, or even a user preference. And fourth, context. Context takes care of the technical details of a conversation, such as saving an entity for later use, setting a default value for a parameter, or clearing contextual information that's no longer relevant. To manage the dialogue state and the context, you get the context map, your own freeform JSON payload. With this, you can provide anything that is relevant to handling user queries in the scene. You use the context map to store specific information about an extracted entity and to carry the results of client-side operations. Once you're done with composing the graph, you can test it directly from the UI by connecting the power source to the flow, like you would do when building an electronic circuit. You can then send messages and set or update your context map just like you do from Unity with Voice SDK. When testing different scenarios, you can visualize the path taken and debug it at every step. Once you're happy with the results, you deploy the flow so it can be used in your app voice experience. With that in mind, let's build a pizza ordering experience. While iterating on the conversation map, we'll also look at an example VR application that uses the very conversation flows we've built. First, we're looking to support adding items to the order. We start by letting Wit know when the user is approaching a waiter NPC so we can greet them. We're then using a custom intent order with custom entities, pizza, size, and pizza type, like pepperoni. The flow starts with an input and then branches using a decision to provide different responses, a couple for actual pizza ordering requests and another to catch everything else. We're using context operations, save, and copy to format the composite entities into arguments for the response.
Hello, and welcome to Pizza Time. What can I get you?
Hello.
I didn't get that. Try I want a large margarita.
I'd like a small veggie, please.
Got it. A small veggie.
Next, we want to ask the user for the pizza type if it's missing and to set the default size as medium. We're adding another input to gather more information from the user and the context set operation for the default size. Then, we'd like to confirm that the order is complete. We'll use the provided built-in intent with negation to understand objections. If the order isn't complete, we support further additions from the user. Now that we support multiple items, we need to save each one into an array in the context map. We'd also like to give a summary and confirm with the user that the order reflects what they want. To do this, we'll include the order summary parameter in a response. We take advantage of the built-in intent with confirmation before proceeding further. We set a make summary action in the response so we know when to format the order summary and add it to the context map, and then the response can use it. Finally, we process the order and return a confirmation number. It's not enough to say that the order is complete or you got it. We also need to actually send the order to the restaurant. This is what our action process order will take care of.
Hello, and welcome to Pizza Time. What can I get you?
Hi, I'll take a large margarita pizza.
Got it. A large margarita. Anything else?
Yeah, and a regular veggie.
Got it. A medium veggie. Anything else?
Nope, that's it.
I got a large margarita pizza and a medium veggie pizza. Does that sound good?
Yes, it does.
Perfect. Processing your order now.
Thanks.
All set. Your order number is number 23. Thank you.
And there you have it. Using Composer in Unity with wit.ai, you can now support rich conversations in your app voice experience in a simple way. Give it a try.
We believe Voice SDK and Presence Platform have the power to enable truly immersive experiences. So check out developer.oculus.com for more resources, samples, and documentation. We can't wait to see and hear what you will build.